Next, we are pleased to welcome Liang, the founder and CEO of Deep Computing, for his talk. Please welcome Liang.
Hopefully we will get another surprise guest speaker, RVA, join me as well. We talk about all the softwares.
Have some applause.
Yes.
With Brian.
Yeah. And we did this talk back in Red Hat Summit, and basically I think just now you can see Charlie explain most of the hardware coming, and then getting more and more high performance. I think we need more software effort, and on get RISC-V into the last stage with better supports. So myself is a founder of Deep Computing.
I'm Brian Harrington, also known as Redbeard. I represent Red Hat within RISE and where I sit on the technical steering committee, and I'm also the chair of the distro integration working group.
Yeah. So and today we talk about how we're going to move forward onto the fundamental thing on the software, which is Linux kernel. How we get I think most of the AI now, the data center or the AI accelerator, they have a concept called day zero deployments. How do we get the software ready for the chip, not the chip waiting for the software? So this is very important. So, and as I say, and just grateful for people who don't know me, I founded Deep Computing. I'm a software guy. So I follow ideology from Alan Key saying that, right, don't trust the hardware guy. So let the software do the hardware. So that's why I wasted all my money on the main board. So shouldn't, and probably do some other crazy things. So.
Yeah, and as mentioned, I represent Red Hat in a number of technical areas. I work in the office of the CTO and spent time, I helped launch another Linux distro in the past called CoreOS, and I've been a product manager on components of Kubernetes, including service mesh things, and I'm also a hobby cryptography breaker and other things like that.
So off to I think.
Yeah. As Ludai mentioned earlier, RISC-V is an open specification, which is really important to the development of modern computer systems. It allows for a lot of areas of transparency into how the actual processor is working that is not exactly what we've had in the past. And it's really exciting for me as a software enthusiast to be able to have a much deeper understanding of the hardware that I'm trying to work with without having to get into a situation of signing NDAs or paying royalties. It makes it a lot easier for me to do enablement of software in the future. Okay. So along those lines, the design of processor intellectual property has a nuanced meaning. We covered a lot of this earlier. In hardware, design is often going to have a verified design for a lot of individual components like USB controllers and other components of the system. And a customer is then licensing something akin to a software library, but often with guidelines for the processor design kit or the transistor layout to make sure that it's optimally laid out for that specific manufacturing process. So when we go to glue it all together, the licensing may go all the way from the top to bottom. In the case of an ARM core, often most of the things are licensed, but RISC-V offers the opportunity for processor designers to break free from that historic model that we've dealt with. There is, as was mentioned earlier, through Chips Alliance and some other groups, there is an increasing amount of Libre IP, but just like with open source software, that does come with some of its own challenges. In the open source software land, we like to joke that open source software is like giving someone a free puppy. Hopefully they will take that and they will groom it and love it and take care of it. It's not something that you can just use part of it and then ignore it. You're going to have to maintain part of that. And so that's where the value of licensed IP also comes back, because that's where somebody else gives you the opportunity where they can act as the dog walker or the dog groomer to help you with that, so that you're not you don't have the full burden of that maintenance on your own.
So back to me, I make motherboards for probably now coming to the 4th year. I still think feeling the painful of it, and because of the software ecosystem. So in 2003, I do a 4-core, 2004.
I'm trying to make your life
core.
better.
Yep. And it does runs all the I would call it when the kernel or when the binary is distro, which is not great. And basically not upgradable. And then later on, I give up doing my all the full laptop and products, and then I just do motherboard for framework, very famous. You guys can take a look on the booth on the framework. You can do a modular replacement, upgrade, everything. So, and you in 2005 we make a 4-core, and then in 2009 months later we make another 8 cores. With 50,000. Now the 2006 early this we announced a 16-core with the RVA23. So RVA23 first RVA23 you guys can go down to the booth. It's usable but still got a lot of problems. And the painful things I suddenly realized that if we do not solve the Linux kernel, and basically what happened is that when the SoC come out, when the IP comes out, it's stuck with the old kernels. It will stuck there forever. Because the horrendous process to upstream the change for the mainline of the kernel to accept it is taking forever. So give you an example, and Sci-Fi's IP, 2018. So for SoC come out, took 4 years, and then for the product come out, and then another 2 years. So the upstream for it is, you can see, you will say back in 2023, took how many years? 5 years, still haven't finished all the upstreaming. So basically, this chip is die with the old kernels. So what happened to RISC-V? You die with the old kernel Linux, you die with all the old tools, no improvement. And RISC-V's optimization coming in the futures, not the current version. So that is the major problem if you don't upstream. So for example, like Andy's doing the IP, I would suggest them, you will start doing the upstreaming when you're in the FPGA. Now, instead of waiting for your customer to take it to the SoC. That's taking far too long. So, and Sci-Fi didn't do it well, and still only on the P50 upstreaming done on the CPU side, even though the IP already for 6 years.
From the operating system perspective, like at Red Hat, what I would say is important to us is that, many of you would be thinking about introducing different chips with your explicit custom extensions, the functionality that differentiates each of you and makes what you are building specific to the market and gives you an edge. But at the same time, from the software ecosystem perspective, it becomes a combinatorial problem because, at Red Hat, we attempt to ship for each ISA a single kernel. And that means that with that single kernel, frankly put, we need those patches to be in the upstream so that we have the verification of many, many users. Because if you imagine a single vendor having to maintain those patches, it becomes an increasing burden over time where as things keep changing in the upstream Linux kernel, the vendor who holds those patches now has to go through with every single kernel release and remake all of those changes, oftentimes making the same changes with every single release. And it becomes a maintenance burden that shifts who is paying the cost long term. And frankly put, when you push things upstream, it makes the cost lower for everyone, from maintainers to manufacturers to consumers.
Yeah, exactly. I think that probably applies to all the whole CPU style of RISC-V. Regarding accelerator or embedded world, might not apply to it because they never need any software upgrades. But if you go on to Android, you go on to Linux distro like Red Hat, going to data center, you cannot avoid it. But all these software practice, I would suggest, regardless, and your embedded or a high performance, you should adopt it anyway. So, and this is the process. I think in the coming Italy RISC-V summit, we're going to have a big discussion. How do we solve the fragmented Linux kernel support for RISC-V? So, and do participate. And you can see, this is not a new thing. Remember, RISC-V is not a new thing. ARM is not a new thing. x86, and people haven't done it for 20 years. Why RISC-V had to repeat all the mistakes? I have no idea. So that's probably come down to Alan Key says that don't trust the hardware guy. So this is the new, the process been there for 20 years. But none of the RISC-V guy and doing it. And the reason being is that not the fault of the way we're doing it. I think we emulate too much on ARM. ARM doesn't need upstreaming to sell 1 million volume per SoC. Easy. Right? They have a tablet, they have a mobile, right? Why don't they don't need upstreaming, get it done. They just get one version Android. For example, most of the TV now, still on Android 10. They can sell millions and millions. They don't need a software upgrade. But for RISC-V, we do, because our RISC-V software is not mature until 5 years later, right? So that means that we're back to the x86 way. We do exactly the same work x86 25 years ago. So to follow the process, I think Greg going to talk about it in Italy and hammer it, trying to solve all this. And the politics of it is that, and upstreaming is a really bureaucratic process. We talk about it. This is the painfulness. I push. First thing, I get some money off SpaceMeet, and then try to blind everyone to help us. How do, trying to get a silicon guy not leaking their so-called confidential information into while they're doing the software upstreaming. Hardware guy is very protective. He doesn't want to leak all your design of SoC while you're doing before you launch. So the willingness check is that it's very difficult. So and I managed to convince SpaceMeet to do it. So they leak all the information, and the other thing is that we did crack back to the maintainer, all the RISC-V maintainer in this kernel is all ARM based. So for ARM, the hardware comes out first before they upstream. Those containers are used to those way. Instead of back in the x86, they're very open. Even you upstream a buggy code, it doesn't matter. But for ARM maintainer, they will say, oh, you better get a very stable one patch before you upstream. And a lot of other things that comes while we're doing this practice back in. We see that if you don't have inheritance from the SoC design, I'll give you an example. SpaceMeet K1 to K3, that two SoC, they share majority the IP, probably 60%. And then luckily, they have done a very good upstreaming on K1, spent 2 years after the chip comes out. And then those upstreaming code can be reused. So the rest of that, for K3, they just need to do 40% of the SoC of the upstreaming coding. So the effort is dropping. The earlier you're upstreaming, you have a generation and you reuse all the IP, and that will be better for the software support. So our recommendation always saying that you find all those IP that Linux kernel support to make a SoC. Don't use a new one. The new one is going to be crap on the software support. So for example, back to the most difficult one is the display. The display is the GPU things. This is another mountain we're going to climb. So, and upstreaming so far, even for NVIDIA or AMD, and they're supporting forward compatibility is really bad on that GPU.
Yeah, I would say
any display, HDMI, DisplayPort, whatever, all this stuff, or those alliance run is the forward compatibility is really bad. So.
Yeah, the most painful part for me when it comes to the different IP components is generally the display controller. There's not a lot of good options there when it comes to the drivers. But to Yuning's point about the SpaceMate K1 versus the K3, the fact that there was so much common in the IP design has made it so much easier for us to hit the ground running from the software side, being able to enable everything from the firmware all the way up through the bootloader, the kernel, and system applications.
Yeah, and the other way is another thing, funny thing I compare to back on the x86. People actually develop the software on the Linux mainline for the new hardware. But when we move to ARM, people is working on the old stable kernel, means old kernel, to support the new chips. It's completely opposite way. So that means that because you work on the old kernel, the longer you drag, you get your chips of software stable. And the difference, the bigger the difference is from the mainline. Then cause you huge effort to migrate to the mainline. So I would suggest all the RISC-V guys, if you want to have a good support of software, especially Linux, go back to the x86 way. Develop your IP on the mainline. And then backport to the stable kernel and harden it, not the other way around. So, and yeah, this is the how do we do the first project of upstreaming before the chip comes out. And yeah, we find a lot of problems. So, and SpaceMate initially didn't want to open up all the code, all the secretive things, but private repositories trying to share with all the maintainers. But all the maintainers actually is their competitors. Work for their competitors. How this thing works, I don't know. So I forced SpaceMate to open up everything public repository. So did everything. I say no one compete with you in RISC-V. There's only one RVA23 SoC this year, probably next year as well. So there's no more secrecy. And also, you will find out, and after I open up this thing, first one scream is the Greg saying that who the hell designed this hardware? So actually, the hardware guy designed the chip without the software glue to give feedback. Usually you do really bad job. And even you have all the conservative reason for making the hardware cheaper. So all these things are very typical. I think I would suggest here, whoever doing the RISC-V, and go for all this and make sure they don't repeat people's mistake, and then make sure IP, SoC, faster support, achieve day zeros deployments for your customers. So what we can improve, it's just upstreaming is all about sharings. So if you got it, and also I think it's more about after you've done the upstreaming, your time to market is faster than anyone else. If you dare to do it, that means you're faster than your competitor. That means your speed is faster. Then you don't mind people copying you, right? Because you're always faster to the market, ahead of your competitor. So that's some recommendations. So consistent side, use all the IP already upstream supports, right? And also when you do an upstream, do all those common feature first, simple one, not those SoC proprietary one like the codec or these things. And back to it is the work on the mainline first, and then backport to the stable kernels. So that's how our software guy look at the RISC-V hardware. And yeah, come and join if you guys help on our Linux support. Thank you.